Next, we're going to discuss structs. Now, structs in Go might seem very similar to a class in another language. These are just a collection of fields. So in Golang, a struct is really just creating a new type with a set number of types within it. So let's create an example. And we do this by using the term type, and then we give it a name. Let's do address, and then the keyword struct. Now we can define the fields that we want in here. So we might say street, city, state, zip. So now we also have to give these a type. So let's say this is a string. These can all be strings except the last one. We're going to make this one an integer. Now if we save, it'll auto format. One thing to note about structs is that the casing of the name matters. So if you start your name with a lowercase, these fields will be private. So if we want to make them public, we would just simply uppercase it. So street, city, state, zip. Let's give it a name. Now, what does it mean by public and private? That just means that within this package here, we can access the internal fields of this struct. If we were in another package, we would not be able to access city, state, or zip. So this becomes very important when we're trying to, say, encode or decode a JSON. You would need to have each of these as uppercase because we need these public in order for that to work. And I'll provide an example of that. Now, there's mainly two different ways to instantiate a struct. Let's do the first way, which is using the var keyword and address. So this is one way to do it. Let's print it out. And let's see what happens. Now it looks like it's printing a bunch of empty characters within here along with a 0. And what this is called is the 0 value. So we basically haven't given the struct any information yet. So that means name would be an empty string, street would be empty, each of these would be empty, and the 0 value for zip is 0. So that's why you see a 0 there. Now another way to instantiate is to use the : equals method. And in order to do this, we need to specify the curly brackets on the end. And those two are equivalent. I normally opt for this method over the other. It's just a preference. Now if we want to set any of these fields to a certain value at the very beginning, what we can do here is we can say name Nick, and we don't have to specify any others, or we can add more in there if we want. You can see that it's printing out the value there. Now let's suppose we want to access some of these other fields after we've created it. We can do that by using the dot operator, a dot, and our IDE will actually help us. Let's say we want to name the let's say we name it home. There we go. Let's say we want to pass a struct around and change the variables within it. As we can see, we defined this address here within this function. If we want to pass this address around to another function and change a value inside of it, we would have to use a pointer. So let's do an example. Set home, and we're going to call this a address. And let's call a name home. So if we called set home on A, would it be printing Nick or would it be printing home? And we can see that it has not been changed. This is because we're passing it by value here and not by pointer reference. So we can fix this by just placing a star here, and then we can pass it an ampersand there. So the ampersand here is saying, let's take the address of A, as we remember from the previous lecture on pointers, and pass that address, which is a pointer here, and then we're changing the value of name to home. And so it's been updated. Now, let's say you're calling a bunch of functions and you'd rather not use this ampersand in a whole bunch of different places. What you can do instead is you can say, I'm going to create an address pointer up here with the initial values there. So we can do it like this instead, which is a bit cleaner. So let's run this. And you can see it's actually printing the ampersand, meaning that's a reference to that struct there. Now, another thing you'll notice is that we can access the fields of a structure by using the dot notation, such as right here, a.name. Even though this is a pointer address, we can do the same thing up here, a.name equals. So even though we can do, I just changed this to a non-pointer here. So this notation is the same, a dot, and the field name, whether it's a pointer or not a pointer, will give us access. In other languages, you might have seen this type of notation to specify dereferencing the structure, but in Golang it is just a dot, which makes it very easy to use. Okay, next we're going to talk about adding methods to a struct. Now in order to do that, methods on structs are just functions, but they have just a little bit different of a signature. You start with the func and then a parentheses, and what it takes is a receiver. So I'll explain that in just a second here. For now it's just address. Let's call this set home. So the function name is set home, and this is the receiver. So what it means is we're just passing in the instantiation of this object here into this function, and we can actually access it from within here. So let's say this is a.name equals home. Now we can call a.setHome. And let's print this. Now you can see that just like in the other example, in a function, we're not actually changing the variable, the underlying variable that's defined up here. This is being given a new value, which is a copy of the other one, and we're changing that. That's why this helper is trying to tell us that it's not an effective assignment. So in order to fix this, most of the time you're going to see a pointer receiver like this on your methods. So let's save this. You'll see that that helper message is gone. We're going to try running it, and now it's updated to home. Now let's use structs to read in a JSON file. This will be more of a complete example of an actual program that you might see. So what I've done so far is I've created this file, and it's just a JSON file with different types here: name, street, city, state, zip. And then I gave them all values here. And you'll see that those names line up to these names. And also I've created these as public field names. So what we're going to do is we're going to read the file in from the operating system. And all you have to do is start typing OS, read file, and then give it the file name. Now, we don't have the package OS defined up here, but if I save this, it'll automatically add it there, which is a nice helper. So read file, we can hover over and we can actually see that it returns a byte array and an error. So the byte array is where all the data will be. So we'll call it data, and then the next value is the error, and we're going to create, this means we're going to create two new variables there. And we're going to check for if there is an error, and then we'll just panic if there is one. This could happen if, let's say, I typed the name wrong. Now let's parse the JSON. So with this, we're going to use the JSON package, which is unmarshal, and it takes data, which is an array, and then v, which will be our new value of the address. So we need to actually create a new variable here. Let's call this address. And then it could be a. Now this function also, we want to see, oh, it also returns an error. So we just need to handle that here. Since we already instantiated the error up here, we are just going to create a new variable. If we do it like this, we'll get an error because there aren't any new variables. And we can copy and paste this as well. Now let's print line on the address to see if it works. Now we can see that it read in the JSON file and attached them to each of the field names here correctly. Now what happens if we didn't use, let's say, an uppercase for, let's say, zip? What actually happens is that the JSON package is not able to access a private member, and so it cannot see that we actually have a field named zip here. These field names need to be uppercase, so let's do that here. Now let's say we want to swap city and state around. Let's run that again. We can see that the state is still being attached to beach, which is good, and the city is Beachville. Now what happens if in our JSON file we use something like street name, or it's some other name and doesn't line up correctly? What happens here? You can see that the street is not lining up here. So how we can fix that is by using struct tags, and that is using the backtick, and then you specify JSON because this is the JSON package that is using it. Street name. Let's rerun that, and now we have the street name in there. So by default, what happens is this is really there. It is just the name of the variable is what's there by default. So you don't have to specify this if you expect everything to be this name, but it is actually good coding practice to always include the tag name so you can see what's being parsed correctly here.